Alrighty. Let's go through this bell work. Yep, hang on a second. Thank you. Pass bucket. Boop, boop, boop. All right, so looking at this bell work, we've got the 27 student names are placed in a hat. And after his teacher draws a name, she puts it back each time. So we want to know the probability that Javon's name is chosen 2 times in a row. What are we going to do for that? I know we've slept a couple of times since we probability. What you got? They are independent events. Absolutely correct. Super close, and I see exactly where we got that vibe. How many names is she picking at a time? Just 1. So it's going to be what as a probability? 1 out of 27. Excellent, excellent. 1 out of 27 for the first draw. And since she replaces it, since she puts it back, what is the probability for the second draw? 1 out of 27. How do I find his combined probability? Multiply them, which we can absolutely do. Multiply our 1 over 27 times 1 over 27, which we could do in the calculator, or we will do in the calculator. Good gravy, not should do, will do. I'm going to open up my calculator, and we can do that because I'm going to remind you of my favoriteest button, where I can do my 1 over 27. You can even come over here and go times another fraction, 1 over 27, and multiply them this way. It gives you the simplified version, 1 over 729, which is great. I love that. 1 over 729. Is that the answer in the form we were asked for? No, because we need this as a percent, which means first things first, I need this as a decimal. Well, when we're in this calculator, this yellow calculator, and we get this fraction, even if I keep doing it, it's still giving me the fraction. So the way you can make it give you a decimal is actually that button above the enter. The little 2 arrows that point side to side, this says switch it forms, where it'll switch it to decimal form. Okay? So if you're stuck in this fraction zone on the yellow calculator, hit those 2 arrows and it'll switch it over to decimals. It can go the other way. It's not always great, especially when it's like 729 denominators, but it's usually pretty decent at it. So we get 0.001. Ooh, 10. 0.001 as our decimal. So what is our percentage? 0.1%. Less than 1%. 0.1%. So he's got a very, 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 very small chance of being picked twice in a row. It is incredibly unlikely. Questions? Okay, we have yet another substitution with this same expression here, where we're making sure we are putting things in carefully, using our parentheses when we're substituting stuff in, because it makes a difference. So substituting things in, we're going to put in our -3 as the b squared minus 4 times our a, which is 5, and our c, which is 9. I know I am funny. I'm not often giggle funny, so if you're giggling, I know you're watching something on your phone, which you're not actually supposed to have out. Put it away. So we need to simplify this as much as we can. What's the first thing we can simplify? The exponent. What do we get when we take -3 and square it? 9. Positive 9 or negative 9? Positive 9. Negative times a negative is positive. If you type it in the calculator without the exponents, it will tell you it's negative. You need to use your brain and remember that that's wrong. Positive 9 minus 4 times 5 times 9. You're getting there? That's the 4 times the 5. We got to include that 9 too. Black times green times pink. 4 times 5 times 9. 180. 4 times 5 gives you 20. 20 times 9 is 180. Again, you can use the calculators to do that. We can also go, well, 4 times 5, we know that. 9 times 2 is 18. Times 10, 180. So you can do it in your head. You don't have to, but you can. Which means, what's our simplified answer? Negative 171. That's our answer. So I can, there we go, that's the whole thing. So this expression, we have seen it repeatedly. We have seen it at this point together about 5 times. On the homeworks, it's shown up most times. This is a thing that comes up, and it is a very common sticking point when we get to it. That's why we're doing these so much. When we get to the, I believe it's chapter 3, when we use these in equations with relevant pieces, and we have more pieces outside of this. This is a piece that is a big sticking point for a lot of people. That's why we're practicing it so much before we even have any context. So questions on that piece? Okay. So this last bit is looking at our two-way tables, which we really started looking at in depth on Friday. So we're using our table to calculate the probability that someone purchased both pizza and soda. So what do we think? What is the probability that someone purchased both pizza and soda? 120. So the people that did both pizza and soda, so that's this group here, exactly right, out of everyone, 400. They explicitly told us to do as a reduced fraction, however. So we start with our unreduced fraction. And we can do this by hand, absolutely. First things first, I noticed that we can simplify by 10. So we can do this in chunks. 120 over 400, so that's the same thing as 12 over 40. If they both have zeros at the end, cut that out. What's the next one we should do? By 4? Totally fine. 12 divided by 4 gives me 3. 40 divided by 4 gives me 10. One of the other things I love about the yellow calculators is I can take that 120 over 400, come here to the yellow calculator and go, oops, zoom in, there we go. 120 over 400, and it can show you the simplifications too. And again, I could hit that button above it to switch it to decimal. I can hit that button and switch it back. So the yellow calculator can help us with that. Okay? Questions on the bell work? Just here. That's just you just type it in as a fraction. So like I came in here and I did my 120 over 400, and I just hit enter like you would for equals. There's one setting that's probably different. You got it? Okay, cool. Yeah, if the calculator ever does something weird, let me know. My pre-cal kids will often have to change setting for things, and they don't often change it back. So if it's doing something weird, let me know. I can help you out because I can reset things. Easy peasy peasy. going to work with these two-way tables some more. We're going to practice all of the relationships. Ooh, I'm jumping us straight into hard mode here. That was a phone. I was like, what's that alarm? We don't have that one. Okay, so on Friday, we were on page 11, and we did A through D. So we're going to work the rest of this one. We might talk a little bit about question 2. And then we're really going to work on page number 12 just so we can practice everything again. Because I want to make sure we go through these things. I've got a homework for us for two-way tables, and we've got a quiz coming up on Wednesday. So we're going to start looking back through some stuff. So we're going to start to do a little bit of review today. We're looking at our unions. I still have the formula up on the board because it didn't get erased. But I'm not going to leave it up there after today. I'm going to erase it today. So we need to make sure we know what to do for a union. Union, I think of it as a wedding. Everybody gets to come to the party, the bride's side, the groom's side, everybody gets to come. So we want to know, so this is question E, so it's the top one of the right-hand column. This union stands for or. So I want to know the probability that someone's in first class. So people in this top row, I'm coloring them pink, or that they got in a lifeboat. This column. So I want to know the probability that someone on the Titanic was in the pink column, or the pink row, or the purple column. The people that could be in either one. It doesn't matter which one, but it could be either one. So the 203 is definitely going to be involved. Definitely. So, but I'm going to start going in pieces here. So I'm going to look just at the first class one, the pink. What is the probability someone's in first class? Yeah. 325 out of 2,201. How many people got into a lifeboat?
700.
Total. Yeah, the 711. Everybody in the lifeboat. So I've got all my first class people. I got all my lifeboat people. And then we've got to be really, really careful because when I counted my 325 people and my 711 people, how many people did I count twice? I was like, look for the crossing area. Where did they cross? The 203. So I'm going to add together my first class and my lifeboat. So I want to know how many of those people is. How many in why am my talking is not happening in the today? Oh my gosh. So I want to combine those two groups together. So we're going to add those two pieces together, but we have to be super duper careful because there's that one group, that 203 people that we counted twice. So we have to take away that group we counted twice. 2201. 203. Indeed I did. Clearly, my brain has not yet booted up on this Monday morning. I have to drink the coffee to make the brain do the thinking. So when we're adding these together, they all have the same denominator. So we can just go across. Our 325 plus 711 minus 203 is going to give us what? 833 out of our 2201. Which we could absolutely get as a decimal. Again, I'm going to do it in the calculator so we can practice it. Second column, third button down gives us our fraction. Got our 833 over 2201. And it just goes straight into a decimal. If you can't simplify it, it will go straight to the decimal. So we have 0.378, taken 3 decimal places. 0.378, which means what percentage of people were either in first class or in a lifeboat? 37.8%. Questions on that one? So we haven't done a union in several days. And those are the weirdest ones. Okay. We're going to do another union. So I'm going to erase this pink and purple highlight. Because the next one is also a union. So we are looking for the probability someone's in third class, bless you, or in the crew. Oh. So we want to know the probability. This is what I call my broke folk group. Third class knows how to do a good party, but they were not super expensive tickets. And our crew. So we're looking for the probability that someone's in one of these shaded regions. What is the probability that someone was in third class? 706 out of... What is the probability someone's in the crew? 885 out of our 2201. How many people did we count twice? None. They're separate rows. These are entirely different data sets. There is no intersection. My intersection is empty because we wouldn't have somebody that was both working on the ship and paid for a ticket to ride the ship. That would be a silly choice to have made. Okay, so if they were in both third class and crew, they would have paid money to go to work. So we don't have to worry about the intersection too much, but it's good for us to check, and we still add these together. Still combining our probabilities in order to make the union. So what is the probability that someone was in this broke folk group? 1,591 out of our 2201. What is the decimal for that one? 0 point. I'll give us that. Yeah. 732 or 723? 72. Just be careful with our roundings, because I've heard several different endings for this one. So just be careful. Which means what percent of people on this boat were kind of broke? 72.3% of people on this boat were probably pretty poor. Didn't have a lot of rich folks. Just the ones that they had were rich. Okay. So again, unions we haven't done in a while. So for us to go through. If you have someone napping next to you, poke them. We got a quiz on Wednesday. We got a quiz on Wednesday, y'all. Oh my gosh, what? We should not be napping. All right. We're going to finish out Titanic with these 2 questions. Head up, my friend. All right, 2 more. And then we'll probably just do the table on the right because it gives us that another big rundown of more probabilities. So this is our new one on Friday, G. where we had the vertical line. This was our conditional probability was its name. And it's because we know something about it. It has a condition. So when we're reading this, do we remember what we read that straight up and down line as? So we read this as the probability that they did not get on a lifeboat. What do I say for this piece? If I know they were in third. So I know they were in third class. They are, for sure, guaranteed to be in this row right here. I know it. They're there. I do not need my first class or my second class. I do not need my proof. They are in the pink row. Guaranteed. What is the probability they didn't get into a lifeboat if they're in that row? 528 out of 706. 528 out of 706. The ones that have the line are the only ones where our denominator changes. The conditional probabilities change our population, change who we're looking at. We're no longer looking at everyone. We've locked it in and zoomed it in on third class. So as a decimal, 0.748, which means what percent? 74.8%. And then that's different from H. It's similar but different from H because we're still talking about our people that were in third class that didn't get in a lifeboat. But H says what's the probability that someone was in third class without a lifeboat on the ship. So how many people were in third class with no lifeboat? The 528. But this time we're looking at out of how many humans? 2201. Okay. So these both had that same numerator, but it's different denominators, and that makes a big difference. Makes a big difference. What's our decimal on this one? 0.2, I was going to say, isn't it like 0.2399 or something like that, where if we round it, we wind up with, or something around there. Here, we'll just do it. Boop, boop, so we can see it. Just because I didn't write it without rounding. That was on our, boop. I trust you guys, but I'm just going to talk it through so we can see it. Our 528 over our 2201. Yeah, so we got 0.23989, blah, 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 blah. If we take our 3 decimal places, this tells us when we round, it's going to go up. But since that's already a 9, it's also going to make this guy go up. So our rounded to 3 decimal places actually even drops this down to 2. It's 0.240 because that rounded up. So be careful with our roundings, because this one should be 0.24, which gives us 24%. Questions on our Titanic stuff. If you are a Titanic person, like that was your vibe and you were like that, I highly recommend number 2. It's really awesome, but it does the same question about 5 times, so I'm not going to have us do the same thing 5 times in a row. So we're going to look at page 12 just so we can practice working through our probabilities again, go through every different kind we have. It's a different table, so it's a different feel. So we can practice going through this stuff. So we've got a bunch, and we should be able to get through all these probabilities and hopefully questions 2 and 3. Should be it. So what is for question A here. What is the probability that someone was a boy when we took the survey? 100 out of 152. As a decimal, .658. So as a percent, 65.8. We aren't always going to have to do all of them. When we're doing these tables, especially on things like quiz and or test when we get to test next week, I need you to write me the unsimplified fraction and whatever method they ask you to. So if they say percent, give me a percent. If they say simplified decimal, or the decimal, give me the decimal. If they say simplified fraction, give me the unsimplified and the simplified. Because the unsimplified tells me where the heck that came from, so that I can make sure you're looking in the right place. Okay? It's not me being petty, it's because my psychic powers aren't here yet. I tried, but they're not here yet. So for the rest of these, when we're talking through this, let's just go ahead and do them as the unreduced fractions, because that's the important part. Y'all know how to type it in the calculator now. We good. So what is the probability that someone's a girl? 52 out of 152. What was the probability that someone said they liked cats? 73 out of our 152. What is the probability somebody said they like dogs? 79 out of 152. And any of those we can type in the calculator, get our decimal, get our percents. Like, practice that a lot of times. We should be all right with that part. Questions on those four. We just kind of plowed through these pretty fast. Okay, the right-hand column goes through the weird ones again. We're going to do the weird ones again. And it's all stretched out weird, and that's so fun. So E talks about the probability of C straight line G. So the probability someone likes cats, if we know it's a girl. Say it louder because I'm old. 41 out of 52. I know they're a girl. They are for sure in this box. I'm going to do it as a box, not a highlight this time, just so we can see it in a couple of different ways. I know they're in that pink box. So the girls, there were 41 girls who said they liked cats out of the 52 total girls that we asked. Not saying that is a universal percentage, not saying that is a universal information of the humans that we asked. All right, so our next one's a union, so it's going to be a little bit weird. So be careful, because we've got the whole party. We've got the probability that someone likes cats or that they're a boy. So they could like cats, they could be a boy, they could be both. We got to make sure we don't count anybody twice. That was a weird shape. There we go. So what is the probability that somebody likes cats? 73 out of the 152. What was our probability of boys?
Boys that like cats or just boys?
Boys in general.
100 out of 100.
Yeah. So when we're looking at our unions, we take our general categories. I take my just cats, I take my just boys, and then I say, all right, did I count anybody twice in that? Did we count anybody twice in that? Yes. How many people did we count twice? The 32. So we got to take away the 32 boys who like cats from this count because we can't count them twice, even though my son is definitely in that group. Absolutely. We have a little special needs cat, and that is his buddy. We are besties. So we are going to add these together. What is our unsimplified fraction for this union? 141 out of 152 are people who either are boys or like cats. Two more, and then we'll be done. So we've got another of the given ones, another one of these conditionals. So what is the probability somebody likes dogs if I know, that's the line, if I know they're a boy? 68 boys who like dogs out of 100 boys we asked. So 68 out of 100. Last one. We've got that intersection. Again, very similar to the one above it, but not exactly the same. What is the probability that someone is a boy and they like dogs? Remember that one upside down, that's our and. 68 out of everybody are 152. The only ones with different denominators are the ones that have the line. Okay. Questions on our two-way tables? We see these a lot. These get hit a lot. These show up on things like SAT a lot. We love two-way tables. They come out frequently. So, I'm going to hand out homework 4. This is the last homework before the quiz. It's going to be due on Wednesday. You guys also need to, not up there, but you also need to turn in homework 3 today. So homework 3 needs to get turned in. You guys can start homework 4. It is our two-way table stuff, so it's not different than what we did on Friday. I just did you guys like 2 homeworks at the same time. Because that would have been quirky. Alright, I do have up here, you guys should be, most of you hopefully have your computers, your Chromebooks, things like that. I know they're still working on some of it for some people, but tomorrow we're going to do kind of an overarching review of all the things we've done so far so that we're ready for that quiz come Wednesday so we can make sure we're in a good place. Okay, so I highly recommend bringing a computer tomorrow. Not saying you can't do without a computer, but it's a game and there's prizes. Yeah, that's fine with me. I was like, and you might be able to do it on your phone, but it's not a Kahoot. Yeah, it'll work on your iPad. Yeah, it's not Kahoot, but it's kind of similar, but it's like a review game. I'll pull out the treasure box. We'll do prizes. It'll be a vibe. But if I ever need you to bring your computers, I do try and tell you guys beforehand because this is not a class where we typically need them. And I'm going to put up here, just as a reminder, turn in homework 3.